Hello everyone, I am Amit Kumar, Assistant Professor in IT Department. Today I am giving a brief introduction about the machine learning techniques, which is in the third year, and I am going to give the basic introduction about the machine learning. So today we will discuss some topics here. What is learning, types of learning, well-defined learning problems, and designing a learning systems. These are the first module's topic. So we are going to be doing. So what is learning? The definition of learning is a computer means what is machine learning definition? It is given by the Tom Michel, but it is not a proper definition of the Tom Michel. This is the proper definition which is world is have the machine learning definition. So the definition he has given is a computer program is said to learn from experience E with respect to some class of task T and performance measure P. If its performance at task T as measured by P improves with experience E. There are three words P, E, T. P performance measure, E experience, and T some task. If a student is going to be, if as a faculty we have giving some tasks to the students and the students is performing the task and he is gaining some experience E. So this experience improves, so it is known as the learning of that student. So here for the machine learning, a computer is said to be learn from experience E with respect to some class of task T, that is some class task T, and performance measure P, that P if its performance at task T as measured by P improves with experience E, means the experience is improving here. So what here are the examples, some examples of the machine learning. So we are going to be explaining this one. So first is handwriting recognition learning problem. If handwriting recognition learning problem is having, so how we are going to be do? So there are some tasks over there, there is some performance over there, and the training of that one. So experience E, the training experience E. So the task is recognizing and classifying handwritten word within images. Okay, and the performance is percentage of word correctly classified. So here the experience E is that the data set of handwritten words with given classifications. So here for the students, the handwritten recognition learning problem, here the task T is given, performance P is given, and the experience E is gaining. Now next example, as I have took a robot driving learning problem. Task T, driving on highways using vision sensors. Performance measure P, average distance traveled before an error, and training experience, a sequence of images and steering commands recorded while observing a human driver. Means if a robot is driving the car in the road, so what is the task? The driving on the highways using the vision sensors. They have the sensors and they have the lots and lots of codes over there that what should have to do, what is the traffic rules of there, and the performance P, the average, what is the performance? The average distance traveled before an error, means how much the distance he has covered or the car has been covered, and the training experience E, the sequence of images and storing commands recorded while observing the human driver. So here are some training experience, that image of steering and the commands is going to be done. Next example, I have took a chess learning problem. Task T, what is the task? Playing chess. Performance P, percent of games won against opponent, and the training experience E is playing practice games against itself. So when you are playing a when you are playing a chess with a bot, then this is the task, and the bot will check how much percentage I can win or opponent can win, and the experience E, that the playing practice games itself is a experience. So the definition, a computer program which learns from experience E is called a machine learning program or simply a learning program. Such a programming sometimes also referred as a learner. Next topic is components of learning. There are basic components of learning process. There are basically categorized into 4 parts. First is data storage, second is abstraction, third is generalization, and fourth is evaluation. So this is the diagram where all the things are given, where the data is storing, how the abstraction is working, how the generalization is working, and after evaluating how much machine learning techniques or machine learning model has been accurate. So when the data is going to be stored, it is with the data, and the concepts of the machine learning approaches are under in the abstraction part, and what the generalization part took the inference of that one, and the evaluation after the model has been trained, the evaluation is done. So the data storage. Facilities for storing and retrieving huge amount of data are an important component of the learning process. Humans and computers alike utilize data storage as the foundation for advanced reasoning. In a human being, the data is stored in the brain and the data is retrieved using electrochemical signals. Computers use hard disk drives, flash memory, floppy disk, random access memory, and similar devices to store data and use cables and other technologies to retrieve data. Abstraction. The second component of the learning process is known as abstraction. Abstraction is the process of extracting knowledge about stored data. This involves creating general concepts about the data as a whole. The creation of knowledge involves application of known model and creation of new models. The process of fitting a model to a data set is known as training. When the model has been trained, the data is transformed into an abstract form, abstract form that summarizes the original information. Here are some word has been important for that one, that is known as training. The process of fitting model into the data set is known as the training. Here some word is there, underfitting and overfitting. There are two data. If we have to so many data for the training, then it is in the overfitting. If we have to less data for the training, it's come under the underfitting. Now generalization. The third component of the learning process is known as generalization. The term generalization describes the process of turning the knowledge about stored data into a form that can be utilized for future action. These actions are to be carried out on tasks that are similar but not identical. So those what have been seen before. In generalization, the goal is to discover those properties of the data that will more relevant to the future task. The main objective of the generalization is to discover those properties of the data which will be most relevant for the future task. The data which is going to be used for the future, then the generalization is going to be used. Next, evaluation. The last component is evaluation of the learning process. It is the process of giving feedback to the user to measure the utility of the learned knowledge. This feedback is then utilized to effect improvement of the whole learning process. After the evaluation, we are checking that the model has been trained or not. If the model has been trained, how much accuracy he is giving or how much error he is taking. Now, this is the most important part of the machine learning. First is deep learning, and the above of the deep learning, that is the machine learning, and the above of the machine learning, the AI, means the codes which are used in the machine learning, or you can say deep learning. Then the AI is using machine learning and deep learning. This is the part and subparts of the machine learning and AI and the deep learning. Now we are going for the next, that topic is types of machine learning. There are 4 types of machine learning: supervised learning, unsupervised learning, semi-supervised learning, and last, reinforcement learning. So the supervised learning, the example of supervised learning is housing price prediction and the medical imaging, and the unsupervised learning, customer segmentation, market basket analysis, and the semi-supervised learning, text classification and the lane finding on GPS data, and reinforcement learning, optimized marketing and the driverless car. Here is an example of supervised, unsupervised and reinforcement learning, where a person is learning that the robot with itself, that is known as supervised learning. There is no helper or no teacher or no advisor, so it is known as the unsupervised learning. And in the reinforcement learning, the robot is going to be doing some action, and with that action he will get the reward or penalty. So it is known as the reinforcement learning. So the machine learning definition is given by the first is Arthur Samuel in the year of 1959 at IBM. So what he has told, I am going to explain this one. Arthur Samuel, an early American leader in the field of computer gaming and artificial intelligence, coined the term machine learning in 1959 while at IBM. He defined machine learning as the field of study that gives computers the ability to learn without being explicitly programmed. However, there is no universally accepted definition for machine learning. Different authors give the different terms. We give as below two main definitions. So the Arthur Samuel has given two definitions of the machine learning. So the first one is machine learning is programming computers to optimize a performance criteria using sample data or past experience. We have a model defined up to some parameters, and learning is the execution of a computer program to optimize the parameter of a model using the training data or past experience. The model may be predictive to make predictions in the future or descriptive to gain knowledge from data, or both. The field of study known as machine learning is concerned with the question of how to construct computer programs that automatically improve the experience. These two definitions has given by the Arthur Samuel, American leader in the IBM in the year of 1959. Now, this is the most important part. If we are giving the input data as a past data, it will be trained the model, and the machine learning algorithm is used, and this after this the data has learned something, and the data is going to be built some logical models, and it has been going for the output. But if a new data is coming, then the building models is had get from this one, and after that it will go to the output part. And if more data is going to be used, then again it will go for the machine learning algorithm and again build the logical model. So there are two words, propagation and back propagation. We will see in the further slides or further lectures. Now, what are the application of machine learning? Application of machine learning methods to large database is called data mining. In data mining, a large volume of data is processed to construct a simple model with valuable use. For example, having high predictive accuracy. The following is the list of some of the typical application of machine learning. The examples are, for the application of machine learning is in retail business, machine learning is used to study consumer behavior. Now, in finance, bank analyze their past data to build model to use in the credit applications, fraud detection and stock marketing. In manufacturing, learning models are used for optimization control and troubleshoot. In medicine, learning programs are used for the medical diagnosis. Next, in telecommunication, call patterns are analyzed for network optimization and maximizing the quality of service. In science, the large amount of data in physics, astronomy and biology can only be analyzed fast enough by computers. The World Wide Web, the WWW, is huge. It is constantly growing, and searching for relevant information cannot be done manually. In artificial intelligence, it is used to teach a system to learn and adapt to change, so that the system designer need not foresee and or provide solutions for all possible situations. It is used to find solutions to many problems in vision, speech recognition, and robotics. Machine learning methods are applied in the design computer controlled vehicle to correctly to stir correctly when driving on a variety of road. Have given use the developed program for playing games such as chess. Basically, artificial intelligence is going to be used in robotics, speech recognition, gaming, optimization, maximum quality of service. These are the application of machine learning. Now, the next topic is well-defined learning problem. A computer program is said to be learned from experience A in context to some task T and some performance measure P if its performance on T as was measured by P upgrades with experience E. Any problem can be segregated as well post programming learning problems, and it has three traits: task, performance measure, and experience. For the better filter email as a spam or not. Well defining problem, we have three traits: task, performance, and experience. The better For the better filter emails as a spam or not, classify emails as a spam or not, the performance measure the fractions of email accurately classified as a spam or not spam, and the experience is observing you label emails as spam or not spam. A checkers learning problems. Playing the task is playing checkers game. Performance measure percent of games won against opposer, and experience playing implementation games against itself. Now the third is handwriting recognition problem. Task is acknowledging handwritten words within portrayal. Performance measure percent of words accurately classified, and the experience a directory of handwritten words with given example. A robot driving problem. Task is driving on public 4-lane highways using side scanner. Performance measure average distance progressed before a fallacy. Experience order of image and steering instructions noted down while observing a human driver. Now, fifth one is fruit prediction problem. Task is forecasting different fruits for recognizing performance measure able to predict maximum variety of fruits. Experience is training machine with the large data set of fruit images. Face recognition problem. Task is predicting different types of faces. Performance measure is able to predict maximum types of faces. Experience training machine with maximum amount of data sets of different face images. Now, the next topic is designing a learning system. According to Tom Michel, a computer program is said to be learning from experience E with respect to some task T. Thus, the performance measure P and for the task T which is measured by P, and it improve the experience A. Example in the spam email detection. Task is to classify mail into spam or not spam, and the performance measure is how much total percent of the mails are correctly classified to being spam or not spam, and the experience C set of mails with label spam. Now, the next one for the steps for designing learning system. There are 5 steps for the designing of the learning system. First one is choosing training experience, second is choosing target function, third one is choosing representation of target function, fourth one is choosing functions approximation, and the fifth one is final design. So these are the 5 designing learning systems for these steps, and you can use this one. It means if you have choose the right training experience data set, then the target functions are good, and if the target functions are good, you can choose the representation of the target function, and after that the function is approximation is going, and the final design has been done. So these are the first topic that I have given. In the next class I will explain all the things in the brief or more into the concepts. Thank you.